Good morning, class. Good morning, class.
Good morning, sir. Good morning, sir.
Okay, please, can you check for me if I'm streaming live on YouTube? If you live streaming is on YouTube, kindly check for me. Kindly confirm.
Yes, sir. It's live on
Okay,
YouTube, sir.
okay, thank you very much. So those who can join us on Zoom will join on live stream. Okay, we need to start this time. Incidentally, there are less than nine students in the class. But we have to start because of the limited time. And we have to finish this segment of the class today. I understand we'll be having a short test today. Am I right?
Yes, sir.
Okay, good. So I'll make it snappy so that you can attend to yourself. Now, the other time, the last time we met, we are talking about sampling from terrestrial or field habitats. And we talked about the different sampling methods or techniques. Random sampling, systematic sampling, and stratified sampling. We talk extensively on that. We also look at some sampling instruments, including the quadrat, the transect, the 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 grid net, and other things. After that, we now came to talk about sampling from aquatic habitats. All those sampling methods that we talked about previously can only be used in terrestrial habitat. What about aquatic habitat? We also started that one. The method to use depends on the type of organisms you are sampling. And we said it that if, for instance, one is sampling uh, small floating organisms, which are technically called plankton, what can we use? We use plankton, sorry. But it's my hello class.
Hello, sir.
Am
Sir.
I sharing my slide?
Yes, sir.
Yes, sir.
Is my slide on?
Yes, sir.
Oh, what's happening? I can't control it from here. What's happening? What could be happening? Please give me some seconds. Give me some seconds. Let me sort myself out. Hello, class. Am I still on with you?
Yes, sir.
Is my slide showing? Am I sharing my slide?
Yes, sir.
Okay, thank you very much. Okay, now I'm through now. So we also talk about something from aquatic habitats, and we said that the method to use depends largely on the type of organism, and that if you are sampling small float organisms called planktons, what we use is plankton net. This is a typical plankton net. If you are sampling fish, there are two major methods that we can use. We can use the fish net or the gill net. The gill net is a trap. This is the fish net. We look at it last week, and this is a gill. Uh, it's a sort of trap. At high tide, water will cover this trap or gill net. And when they tie receipt, some fish might have been trapped inside the gill. This is used mostly in oceanic habitat. Then what about something from the bottom of the river or stream? We can use the kick sampler. The kick sampler is just a modified net which disrupts the bottom of the pond or the stream. And then as the bottom is disrupted and floats to the water, then you now take them up with the net attached to the kick sampler. This is a typical kick sampler with a net. Then they just disrupt the bottom of the pond, just reflect it, and then some bottom-dwelling organisms and even the sediment will float, and then they are collected by the device. And then to sample from the bottom of deep lake or from marine habitat, we can use the grab or the core. These are more powerful. For instance, now this is a benthic grab. It's made of iron. You know, a rope is tied, and then this is lowered to the bottom to get to the bottom of the ocean, and then the bottom is disrupted, and then the attached gill, the attached net could be used to collect floating sediment and bottom-dwelling organisms. And then this is a core sampler. We also talked about all this last week, the last time we met rather. Now, another method to sample from aquatic habitat is the capture method. What does this technique entail? It is the same method we have been learning from secondary school days. We can use this method to sample organisms like fish, like mobile aquatic organisms or animals rather, like fish, like frog, crab, that's aquatic crab, and so on and so forth. We can use this method to sample it. It's so simple. What do? We make a visit to the pond. We do a capture of the fish. When the capture is made, the fish captured, are counted and recorded as maybe A, we denote it maybe as A, and then they are marked with indelible marks. After which they are released back to mix with their population, and then you go your way. After 2 or 3 weeks, when the captured and released fish will have mixed with their population in the water, you make a second visit and do another catch. This time around, the second catch is marked as B or any other convertible covenant letter, and then they are counted. When you count it, what you have counted is recorded as B. Now, out of the ones you have caught the second time, you probably must have caught some earlier at the first visit that you made. And then, how will you know? You will know from the mark that they bear on their body. So anyone that bears that indelible mark shows that it was captured the first time. So those ones are counted and they are recorded as C. So from that data, you can estimate the population size of that population in the pond by the formula A times D all over C. And don't forget that there's no, if your answer is it's in fractions, don't forget that animals don't exist in fractions. What do? You round up or you round down, as the case may be. So that is that. We have been doing this one from secondary school days, like I said. We also did it in other ecological courses. So I will advise you go back to it and refresh your memory. Now, okay, so the same thing we are talking about here. Now, what about another sampling technique or method is the plant graph. Don't forget that what we just described is sampling aquatic animals. What about aquatic plants? There are devices that you can use to sample aquatic plants. A very good one is the plant graph. The plant graph is made of something like a metal which you throw into the water. You understand? You know, which you throw into the water to harvest some aquatic plant. And then you pull it up. And then you can do your studies. This is now, if you are in the class now, this thing, what does it look like? For those of us who are street compliant, what does this plant graph look like? Has anybody seen something like this? For those of us who are street compliant, is
Looks
the
like
class
a
with me?
fishing hook.
Somebody talk. Let me ask you again.
It
Oh,
looks
yeah.
like an hook.
Hook. Let's hear from somebody else.
Um,
Yes.
so it looks like the hook they used to take used to fetch out draw from Wales.
Oh. This person is street compliant. You understand? We need to be street compliant though. You get it? We need to be street compliant. Sometimes, even if you don't, we are not intentionally. What do we call something like that? That thing you got described. Oloto, gala, isn't it? Anyway, so this is a plant graph. I just had that one to make you remember what a plant graph is. This time around, this is not for taking out dislodged drawer from the water, from the well. But then you see a plant graph. You throw it into the aquatic plant, and then you pull it out. And this hanging hook, we pull out some of the plant, and then you can continue your study on the plant. Okay. So now, what about sampling from the air? We have looked at sampling from the water, aquatic habitat. What about taking your samples from the air? There are also devices that you can use. A good device that is used in sampling organisms from the air is the suction trap. As the name implies, a suction trap sucks in air from the atmosphere. A device is put into one end, which helps to draw in air from the atmosphere. And the air being drawn in can contain small flying insects. And then this is drawn in, and then they are trapped. So this is essentially you know, a fan-like device that will draw in air is attached to one end, and the other end opens to the outside. And then as that fan is switched on, as it draws in air, it also draws in flying organisms into your device. The smallest a smallest suction trap design is the putter. The putter that we learned in secondary school. I hope you can still remember. So that is what the suction trap is telling us. Okay, putter is a simple suction device for picking up small flying insects from the air or from vegetation. Vegetation are plant leaves and plant existing shoots. Okay, so this is what it looks like. This is the mouthpiece through which air is drawn in. Don't forget that that's a container into which the suction hose enter into, and into which the trapping hose also enter into, and then a net is placed into the hose that bears into the suction hose, so that you don't draw in insect into your mouth. So you draw in from this end, and you suck in from this end, and here it's drawn in from this other end. So that's a putter. A putter is a simple suction device. What about the sample from herbage and trees? What are herbage? Herbage are grasses, tall grasses. Tall grasses or the leaf of herbs. That's herbage. Now, to sample from that one, what do we use? We also use suction device, the suction sampler. This time around, a more powerful one that can be able to take in bigger animals, bigger insects. So essentially, it's also a suction device, but it may not be like the one you use to sample from the air. That is one. Another method that you can use is chemical knockdown. Chemical knockdown. Chemical knockdown is the controlled use of chemical to knock down insects. This should not be overused because it is not environmentally friendly. But then, if you have to sample from habitats like the forest, tropical forest, where you have tall trees, you may not have too many choices to make than to use sparingly chemical knockdown. So that is that from sampling from herbage and trees. And then another method to use, apart from suction, apart from chemical knockdown, is the sweep net. A sweep net is used to collect flying insects. This is a sweep net. You just fly it, targeting flying insects, and then the insect is caught into the sweep net. Usually, the amount to have a device that you can easily draw and then close off. That's how suction, I mean, sweep net is designed. Another thing you can use is the insect net. The insect net. They look similar to the sweep net, but the design is somewhat different. So far now, to sample from adjacent trees, we can use chemical knockdown effect. We can use suction, powerful suction. We can use sweep net. We can use insect net. Then what about to sample from the soil or from litter? Don't forget, when we sample from the soil, we are asked to sample soil organisms, especially soil animals, soil-dwelling animals, the earthworms, nematodes, and so on, roundworms. So they live in the soil. So how do the primary aim is to get them out from the soil, to be able to separate them from the soil matrix. So what can be used? Number one, we can simply sieve the soil through. We can pass the soil through a sieve, whereby the soil particle is sieved away, and then we have the animals on top of the net. That is one. Where that is not appropriate, you can decide to use heat or light to drive them out of the soil. Now, what do? You put the soil sample in a funnel-like device, and then you apply heat from the top or light from the top. Don't forget, many of these insects are sensitive to light. So they want to move away from light. And if light will not do it, you also apply heat. As they are trying to avoid the heat and the light, they are migrating, moving to the bottom. And your funnel is there. And before you, okay, this is okay. Sorry, this slide is showing a simple use of sieve. Okay, this is okay. And then, so we are talking about using light and heat. So such devices are called Barman funnel or Togrin funnel. And just a simple, this is it. This is a Barman funnel. You put your soil sample in this place, and then you apply it at the top and light at the top. And then as the animals are trying to escape the heat and the light, they need to move into the tube, which you close and then you open it intermittently, and the animals are captured into your device. So this is a Brahman funnel, which you apply heat and light at the top. This is Togrin funnel. The same design, but different apparatus. This is a funnel, this is a soil, and then you apply this soil. This is a source of light and a source of heat. Of course, as you apply it with higher intensity, the animals will move down into your bottle. Now, the bottle already you put alcohol. Alcohol will help to preserve your insects for further studies. So that is sampling from the soil. So far, we have looked about we have looked at different methods to sample organisms from the feed, from the water, shallow water, that's pond, and deep water, like the ocean. We have also looked at other methods to sample aquatic organisms, like capture the capture method, like fish net, like grid net, and so on and so forth. We also look at sampling from the air, sampling. Now, there are some cases. All these devices and methods that I've talked about. There are some animals that you may not be able to sample. You may not be able to see them directly. For instance, now somebody wants to work on animals like elephant. Is this so much? Except to go uh, to parks and reserves, you may not be able to do direct studies. You understand? Or maybe animals like the birds. They just fly, even if you see it, in the next seconds, it has flown away. You understand? Or what about burrowing animals? These are difficult to sample directly. Now, what can you do? You can use indirect way to sample them, like footprints, like feces, like hair, like nest, like burrows, or even like cat skin, as in the case of snakes. So this is what is meant by use of sign, products, and effects. And then you can also use sign like a damage, like insect damage to plants. There's some insects that you may not be able to see, but how can you know that they are present? You plant your crops. Today the crops are normal, they are growing well, and the following day you came, they're picking up the leaves. So that can help you to determine the presence of those animals in that habitat, in that place. Now, lastly, after you have done your sample collection using any appropriate technique, don't forget the techniques you use for collection is largely dependent on the type of animals you are sampling. Now, when we started this class, the first thing we said was that ecological sampling or study involves three major steps. Number one, you define the aim and objectives of the study. The aim and the objectives. We described those things earlier. After that, you go out to do your sample collection. All those things we'll be talking about, all those methods of sampling, aquatic, terrestrial, sampling the air and the soil, all those still fall within the second step of sample collection. After you have collected your sample, what's the next step? The next step is for you to come back to the lab and do statistical analysis, and then you draw your conclusion or your inferences from the samples that are collected. And that is why now we are talking about statistical analysis. Now, why is it important to carry out statistical analysis? Now, if the samples are collected, if it is just small, if it is a small sample, and you can tell if you can make some conclusions. But then, in cases where you have a large number of samples. Sorry, man, I'm in the class, man. Now, am I back with you? If you are there, let me hear you talk.
Yes, sir.
Yes, sir.
Only two people
Yes,
have talked,
sir.
so. Okay, good. So that is the essence of that in a situation where you have a large number of samples and these things, you have to carry out statistical analysis to be able to draw a conclusion. And there are many statistical tools that you can use. Let us see some of them. Now, usually, before you start your study, or when you are designing your study, before you even start the sample collection, you will do what you call hypothesis. You learn these things in statistical courses as we did, maybe first semester or thereabout, I don't know. Now, what do? At least there will be two hypotheses. Null hypothesis, which is called H naught. You still remember? And an alternative hypothesis, which could be 1, 2, 3 more or more. That's H naught. Null hypothesis, usually it's only 1. Usually. And then you can have many alternative hypotheses. That's you have H1, H2, and so on and so forth. So, what is H naught? Okay. As I said before, statistical to help us to decide if relationship exists by removing uncertainty. Okay. So, what is a non-hypothesis? A non-hypothesis is that hypothesis that assumes that there is no relationship in the studies or the samples are collected. You understand? No relationship. That is a non-hypothesis. For instance, now you want to do a study. You want to see if there are tilapia fish. No. If there is, tilapia is for many species. One of the species is tilapia zile. Now, you go to that pond. You want to see this pond. Do we have tilapia zile or any species in this pond? What will be your non-hypothesis? Your non-hypothesis or H naught will be, oh, in this pond, there is no tilapia fish. That would be the non-hypothesis. You understand? Now, you can only reject, you can only reject the null hypothesis if after you have carried out your sampling study, and then you find that, and then you have analyzed that, okay, I incidentally, when sampling, I was able to catch some fish. I was able to capture tilapia zile. Even at that, you cannot reject your null hypothesis. That is to say, you cannot say that there is tilapia zile in that pond. You can't conclude until you have carried out statistical analysis. Although you have found that, although you caught tilapia, you want to ensure that the tilapia you caught in that pond is not by mistake. Probably, you understand, probably it wasn't there before. So you want to eliminate doubts. You want to eliminate uncertainties. That is the essence of statistical analysis. And to do that, to eliminate doubt or uncertainty, what do you have to do? You have to set limits. And that limit is in the past 2 hours. Before then, let's go on. Let me see what I have replied. So, like I said, statistical analysis help us to decide whether there's relationship or not, or whether what you have seen is due to error or chance. So you want to eliminate the chances of error. And then now, as I was saying, to remove uncertainties from what you have found. Maybe what you have found is not by mistake or because of an error somewhere. You now set a level of significance. In science, that level of significance is usually set at 5%. That 5% is written as P. P value is the level of significance is equal to 0.25 or less. Equal or less, in some cases, you just say P less than 0.25. What is the implication of that? When you set your P value at 0.25%, you are saying that the chances that what you find, what you discovered, what you observe, the chances that is due to an error are just 5%. On the other way around, you are saying that what you have found, the result you have obtained is 95% certain that it's not due to an error. Do we get it? It's the same thing. Saying the same thing in different ways. So that's what the P level is talking about. You did this one extensively when you were doing that course, statistical. I mean, that course you did. That course you did in statistical. So that is it. Then the next question will be the next question will be, okay, so we are talking about level of significance, 0.25%, allowed to say whether it's the same thing I just said. What I just said is what is contained in this slide. Now, what are the statistical tools that you can use? Okay, so now after you have subjected your data to statistical analysis, and you find the relationship, you can say, oh, you can now reject your H naught and uphold your H1. But let's quickly put a caveat. Usually, I mean, sometimes in some studies, especially in science, there are many variables that you are looking at, such that if you are to begin to set hypotheses, you'll be setting so many hypotheses. You'll be having H1, H1, H2, H3, H4, H5, that it becomes so complex. In such cases, you skip setting hypotheses. Why? Because the study is complex and many variables are involved. But if it is a study that is simple enough in design, especially in social sciences, in education, if the study is simple that way, you can decide to begin to set hypotheses. So that is the essence of setting hypotheses. And then after you have rejected your non-hypothesis, you can uphold your alternative hypothesis. So what are the statistical tools that you can use? You can use t-test. Okay, I'm not back with you. If you're in the class, let me hear you talk.
Yes, sir.
Yes, sir.
Okay, good. So what are the statistical tools that you can use? You can use many tools. Your t-test, your chi-square, your ANOVA, your MANOVA. At what point do you use the t-test? T-test is used to compare two samples or two groups. Now, there are three types of t-test. We have the single sample t-test or unpaired sample t-test. You have the paired sample t-test or dependent sample. You have the independent sample t-test. You understand? So when we say unpaired t-test or single sample t-test, maybe you have a result in the past, and then you have a result that you have quantified in terms of number, and then you now carried out a new study. You want to see if that study conforms with the previous study. So that is when you use the single sample t-test. That is one. Two, paired sample t-test. This compares two samples, two related samples. For instance, now, you there's some studies, like in medicine now, they may administer some drugs. Before they will take some measurement, some assessment, before they administer the drugs. And then they will now repeat the same test or measurement after they have done what? After they have given the drug. So that is paired sample t-test. That is to say, the samples are two, but then they are related. And then third, we have the independent sample t-test. This one compares two groups that are not related. So, is that okay? And then you can use the chi-square. You can use the chi-square. The chi-square, the chi-square determines whether a proportion is in line with theoretical values. For instance, now, like in the you make a monadic cross, a diagonal cross. Don't forget, when you cross when you cross two heterozygous parents, what proportions will be the result? What proportion will be the result? So that chi-square goodness of it helps you to determine it. And then another tool that you can use is ANOVA, analysis of variance. You may have many variables, to compare. And that one too is of two types. You can have one-way ANOVA, or you can have two-way ANOVA. So those are the common, sorry, I said two, no, more than two. You can have one-way ANOVA, you can have two-way ANOVA, you can have multiple variables. So we have ANOVA, you have one-way ANOVA, you have two-way ANOVA, and then we have MANOVA. So let me pause here and allow you to ask your questions. Yes, I'm listening to you. Class. If you are there, let me hear you talk.
We are here, sir.
So ask your questions. At that point, we'll be drawing the curtain on my segment of this course. Questions? Questions? Ask your questions now. Ask your questions. So, if there are no questions, we call it a day. If there are no questions, we draw the curtain on my segment of this course. Probably Dr. Fagdaji may still come around to finish up with you. I don't know. But if not, just get ready and prepare for your exam. You have your time to do other things. And then to do your practical. So should we call it a day? Let me have you talk.
Yes, sir.
Okay,
Yes, sir.
Thank you so much. God bless you.
God bless
Thank
you,
you,
sir.
sir.
Thank you,
Bye-bye.
sir.
Thank you, sir.
Amen, sir. Thank you, sir.
Amen, sir. Thank you, sir.
Thank you, sir.
Okay.
Curriculum